So we are going to get started on our next chapter today. Yay! As far as previous notes packets, you might want to hang on to them for when it comes to finals so that we can review with them, but you don't need to bring them with you to class. We're going to be in this notes packet until about middle end of September. So this will be what we're working on. So if you did not pick up one of the new notes packets, come get one from over here. And if you did pick one up, awesome, open it up because we are going to start Shocking of all shocks on this very first page, where we're going to talk about solving specifically. So we are going to practice solving equations, getting down to our answers, very much like we did in the Bell work, where we got our x equals. But we're going to get slightly more complicated things than this. So a lot of us like to have some steps so that we know kind of what we're doing and use it like a checklist. So when we are solving, and this is not necessarily the only way we can go through this, but this is one of those really common and it works for a lot of people and helps kind of things, is if we start by simplifying both sides of our equation. Because when we are given these problems, they're not always entirely simplified. Sometimes we've got kind of chaotic pieces. So we want to simplify both sides of our equation. It makes things simpler to deal with a lot of times. Again, this is not a math law, you have to do it. This is helps a lot of people avoid mistakes situation. So you don't have to, but I strongly recommend simplifying both sides. Then the next thing we're going to want to do is get all of our variables, all of our letters onto one side of our equal sign. We're going to have all variables to one side. So if I have x's on both sides of my equal sign, I'm going to get them to one side of the equal sign. If I have y's, I'm going to get them together. I'm going to have z's, going to get them together. We're going to get all kinds of letters. Once we have all of our variables on one side, then we're going to get all of our numbers to the other. Some places will say numbers, some places will say constants. I'm going to say all numbers. To the other side. And then our very last step is going to be to check and make sure what we did worked. I have up on the very right side of the screen our PEMDAS, just in case we don't remember it off the top of our head. Because when I say simplify, what I mean is we're going to go PEMDAS. We're going to try and simplify anything we can. Parentheses, exponents, multiplying, dividing, and then adding and subtracting. So when we're simplifying, we go this way. If you are trying to get all of our variables on one side or trying to get all the numbers over, and we're looking at this and we're going, I don't even know where to start. I don't know how to pick my first step. A really good option is, if we simplify top to bottom, we actually solve bottom to top. So if we're not sure what to look at, see if you can figure out what's going on with adding and subtracting and how we can move that. Then we could look at multiplying and dividing and see how we could fix that. So you, again, don't have to do it this way, but this is one of those tools we can have for, I don't even know what to look at first, and it takes our too many choices down to just a couple. So if we struggle with what to pick first, think of simplifying is PEMDAS, and solving, we would go backwards, starting with our adding and subtracting. There we go. It says solving. I know the G's off the screen, but it says solving. So this is what we're going to work with for these top 4 equations where it's all numbers and stuff. So our first step is going to be to check and see if we can simplify either side individually. That first step does not cross equal signs. Then we'll get all our letters to one side, all our numbers to the other, and then we'll check. And for the check, we're pretty much going to use calculators because gross. All right. I'm going to go ahead and change it. If you need me to go back, I can. Let's look at A. Our first step said to see if we could simplify each side. We're just looking at this. Is there anything I can do to simplify this side? No. Is there anything I can do to simplify this side? Huzzah! We did it. It's simplified. We did so much work. There's nothing we can do, so we don't need to do anything for that. There's nothing I can simplify on that side. So first step, done. Yay! Now we're going to see if we can get all of our letters to one side. What am I going to do with that 4x? Minus it. If I subtract 4x from this side, I'm going to subtract 4x from this side. If we have things that are being added and added, we're going to subtract it. If I have a positive 4x, I'm going to subtract 4x. That means this guy's going to cancel out and it's going to go away. We're going to be left with 7 on this side equals, what is 9x minus 4x? 5x. And then that minus 12 is still just chilling. All of our letters are on one side. Yay! That step's done. Now we're going to get all of our numbers to the other side. How can I get my numbers over to the other side? Add 12. I want to add 12 to both sides. When we do that, we're going to have our 5x left on this side because the minus 12 and the positive 12 cancel out. And then we have 7 plus 12, which gives us a 19. Yep. Don't have all my numbers over on that other side yet, so we still got to keep going. How do I get my x all by itself? Divide it by what? 5. And if I divide this side by 5, I need to divide this side by 5. As long as I do the same thing to both sides, I can do anything I want. So here my 5 and my 5 cancel out. That's why we divided. I wanted to be rid of it. Then we have our x is the only thing that's left, equals, what is 19 divided by 5? 3.8. And you can put that as 3.8 as a decimal, totally fine. Or you can write that as a fraction, 19/5. It doesn't simplify. You could put it as 3 4/5, but that's really difficult to put in the calculator to check as a mixed number. It's not wrong, 3 4/5, but it's just not easy to use. So I would recommend decimals or fractions. The only time I'm going to mandate we have a fraction is if we have a decimal that's like the repeating kind. So if we had like thirds, keep it as a fraction. Because we don't want to round our answer, because then we've changed it. So this is our first 3 steps right here. We got our x all by itself. Our last step is going to be to check. We want to take this 3.8 and see if it did actually work, if it made these two statements equal. So what we're going to do is I'm going to take my 3.8 and I'm going to substitute it into 4x plus 7. And then I'm going to take my 3.8 and I'm going to substitute it into 9x minus 12. And I'm going to see if they give me the same answer. That's how we're going to check. And the way I'm going to do that is in my calculator. So when we have something like our 4x plus 7, a lot of us are really inclined to go 4x plus 7. But the calculator doesn't know what we mean by x, so it's going, I don't know, something. That's not the answer. What we need to do is we need to take our 4 and we're going to substitute in place of the x our 3.8 plus 7. And then we're going to do the same thing with our right side. 9 times 3.8 minus 12. I got the exact same answer for both of these. So these two statements equal each other. It doesn't matter what chaos we got. All we care is that these two numbers match. Since they match, we did good and we got the right answer. So we successfully checked it. That's all we need to do is we're going to substitute back into our original equation to see if it gives us the right answer. So those are all 4 steps. Questions on this one? I know it's a lot. We're going to practice this several more times. Okay. Equation B. Same vibe. Follow our steps. Can we simplify either side? Can I simplify this side?
Yes.
What can I do to simplify this? Combine some like terms. I got 6.6k and 3.4k. I got 2 sets of k. So we can combine some like terms. It will make things easier if we look for those first instead of trying to deal with everything individually. Because what is 6.6k plus 3.4k? 10k. Oh, look at that. We don't have any decimals anymore. What? So we have 10k plus 8 equals 6k. No more decimals. Woo. So simplifying our one side really did help. There wasn't anything we could simplify over here because there's only one chunk over here. We only have one term. Nothing I can simplify there. So that's what we mean by simplify each side. So then what should we do to try and get our answer? How do I get my letters together here? We can minus the 10k. You could also subtract the 6k. Either way is fine. We're just going to get our k's on either side of the equal sign. It does not matter if the letter is on the left or on the right. It does not. So my 10k and my minus 10k cancel out over here, leaving us with just an 8. And our 6k minus 10k. What do we have there? Close? Close? Negative 4. I was going to say, I think you were just a half step ahead of me. 6 minus 10 gives me negative 4. Fine, totally works. But I don't want to know what negative 4k is. I want to know what k is. So what do I do to get k by itself? By negative 4. Divide by negative 4 on both sides. What is 8 divided by negative 4? Negative 2. So the answer we calculated is negative 2. Then we're going to go back and we are going to check it and see if we're right. So I'm going to go take my negative 2 and I'm going to substitute it in for k on this side. I'm going to take my negative 2 and substitute it in for k on this side. And I'm just going to do those in the calculator. For the check, we don't have to do like a ton of work on the paper. We're just going to type it in. So I'm going to have my 6.6, and in place of the k, I'm going to put my negative 2. It is really important that we use this negative sign, not the minus. The calculator views those as two different things, and I know in our math we have this very, very similar, but use this for negatives. Otherwise, you're likely to get an error. But there's our 6.6 with our negative 2, plus our 3.4 times negative 2, plus 8. And we get an answer. And then we want to see if that's the exact same as if I took 6 times our negative 2. We got the exact same answer. That means we did it right, and we got the correct answer because those two things match. As long as those two things match, celebration. Huzzah! So this is the right answer. We double checked. Okay, questions on these two? We got 2 more here. So we've got C and D up here. And we have different letters here. That's going to happen. We'll start seeing more and more different letters. It's good practice for us. We treat them exactly the same as if they were X's. So now we're going to try and simplify each side of this. So look at each side individually. Can I do anything to simplify over here? What are we going to do? Distribute. We need to multiply that 2 into that parentheses piece. So I need to take this 2 times my 3c and the 2 times my minus 6. The closed parentheses is our stop sign. That's where we stop. Do not continue past the closed parentheses. So we're going to have 2 times 3c, hello screen, don't blink on me, which gives me 6c. And our 2 times minus 6 gives us a minus 12. What about this right-hand side? Is there anything I can do to simplify over here? We've got some like terms to combine. I've got 6c minus 9 minus 5c. So I've got 2 different c's. What do we get when we combine together our 6c and our minus 5c? Say it louder. 1c. For some people, it's really, really helpful to put the 1 with the c. It is not something you have to do. If you just put it as c, that is 100% as valid. They mean the exact same thing. For some people, this is really going to help. If it helps you, write it. If it doesn't help you, don't write it. But now I've got both sides simplified, so now my goal is to get all my letters on one side. What should we do? Subtract 1c. If we always pick the smaller letter to move, so how 1c is smaller than 6c, we will get the least amount of negative numbers to deal with. Again, not something we have to do, but if we are not super comfortable with negative numbers, try and always move the smaller letter. Because 6c minus 1c gives us a 5c. And we've got our minus 12 equals. Our 1c's here canceled out, and we have our minus 9. Now what should we do? I've got all my letters on one side, so now I'm ready to move my numbers. I'm going to start by adding and subtracting. So I'm going to start with adding 12. I add 12 to both sides. That's going to give us our 5c equals, because this guy cancels out. What is negative 9 plus 12? Positive 3. We're almost there. I want to get my letter all by itself. We're not quite all the way by itself. One last step. What do I need to do? How do I get c by itself? Divide by 5. So we can put our c is, and we could get 3/5 as a decimal. That's totally fine. It's 0.6. And you could use that to do your check. Or we could have it as a fraction where it's 3/5. That's totally fine. Either way works. I'm going to show you how to check when we have a fraction answer, because occasionally we're going to have fractions that we want to keep as fractions. As far as answers go, I would take either one. Both are exactly the same amount of correct. I'm going to show you how to check it if we leave it as a fraction. Because we're going to do the same thing. We're going to go take it into the calculator and substitute it in. We just have a fraction to put in. So we're going to get to use my most favoriteest button in the whole wide world on this calculator. Teaser. So when we put this in, we're going to take our 2 times our 3 times c. So you can either do a times, or you can do another parentheses here. Except I want it to go back. You can either do the times, or you can put another parentheses here. Either way, we have to tell the calculator we're taking this 3 and multiplying it by our second column, third button down. Fraction. That looks like a fraction. Ooh. 3 down 5. So I'm substituting for our c here, that's 3/5. Minus 6. Close my parentheses, and we're going to hit go. It is an unpleasant fraction, but it's just a number. All we need to do is look at it. Totally fine. You get the exact same thing. It'll probably just be as a decimal. And if we type that in on the other side again, we're going to take our 6 times the fraction of our 3/5 minus 9 minus 5 times our fraction, 3/5. So we can type it in with the fractions, and we get the exact same thing again. I got 42/5, 42/5. If you did this as decimal, you probably got, oh, better, -8.4. If you're using these calculators and it gives you a fraction and you need to switch it to decimal, use these two little arrows. It switches it from decimals to fraction, and we'll switch it back too. These calculators are awesome. So we checked this. Go team. One left to go with these lots of numbers and letters before we get into a little bit of weirdo stuff.
It was -4. It was -8.4.
Something like that. Let me look. Yeah, -8.4. You don't have to put down the value that you get when you do the check. I'm not going to check those values. I just want us to know that we checked. That's why I just put the big check mark on it. Yes, dear.
When you do it in distribution,
Mhm.
like at the start, the sign, like addition, subtraction that you have inside the parentheses, is it always going to be like the same in the equation?
If you are multiplying by a positive number, yes, it'll be exactly the same. The only time it's going to change is if we're multiplying by, like, if this was -4, then it would change all the signs in here. But I was like, we can just multiply by if we're only multiplying by positive numbers, the signs won't change. So let's look at D. Very, very similar. We're going to start by simplifying each side. So I'm going to do my distribution. And here's where we can really see if I'm distributing this 4 times my 8, my 4 times my minus 3h. Stop here. The 4 does not go to the 14. This is our stop sign when it comes to the multiplication. Do not keep going. The 4 only goes to these two pieces. So we're going to have our 4 times 8, giving us our 32, minus our 4 times 3h, so we have a 12h, and then our plus 14h equals -28. So be careful with our distribution. The most common mistake I see on that is that we just take that 4 and we just go, everybody gets 1. We'll take the 4 to the 8, and to the 3, and to the 14, and to the 28. Everybody gets an 8, or 4. And that's not right. The closed parentheses is your stop sign. We go until we get to one of them. Now we can combine some like terms together. I've got my 32 minus 12h plus 14h. What do we get when we combine these two together? Positive 2h's. What are we going to do next? All my letters are together, so now I move my numbers. Subtract 32 from both sides. Good. I need to subtract 32 from both sides. That's going to give us 2h equals our -28, -32, -60. Be really careful with this. Think about this as somebody owes you $28 and they owe you $32. You do not magically have $14 in your pocket. So it's -60. They now owe you a combined $60. Negative numbers, think about somebody owing you money. We are much better with that than thinking about negatives abstractly. Almost there. How do I get my h by itself? Divide by 2. So we get our h equals -30. And again, we can absolutely check this. Type it into the calculator. It does, in fact, check. I don't want to eat up all of our time because we do need to do some of the ones with the funky letters at the bottom. So we're going to look at A and B in the next section because sometimes you're going to be given way too many dang on letters. And we're going to work with things where we're going to have to solve them into pieces. So the second section is talking about solving for a variable, and sometimes they give us too many. We still treat it the same way. We're going to try and get our whatever letter by itself. Here it's telling us we're going to solve for y. That means I want this to wind up either as y equals or as something equals y. It does not matter which side the y is on, but I need y all by itself. That's our goal. So if we look at this first one, k equals 2yz, and we know we want to get y by itself, I need to get rid of the 2 and the z. I'd want that y to be by himself. What is happening between the 2 and the y and the z when they're all smushed together like this? They're all being multiplied. This is 2 times y times z. Like if we think about it without the z, we're usually pretty good at figuring out what we need to do. How do I get rid of that 2? We divide it. Doesn't change when we have the z there. Anything that I need to get unmultiplied gets divided. I want to get rid of that 2, and I want to get rid of that z. I put a little crossbar on my z's just because otherwise my z's look like 2's. My handwriting's weird like that. So whatever I do to one side, I do to the other. I'm going to divide this guy by 2 and z. That way my 2's cancel out on this side. My z's cancel out on this side. And we're going to have all by itself here a y. My left-hand side is going to look crazy. Because can I simplify anything here? Nope. My y equals this really ucky fraction of capital K over 2 times z. When we have too many letters, our answers will probably not look better. They may look worse. But that is our answer. When we have too many letters, we also can't type it in the calculator to check. We have to have faith in our abilities. Because this is our final answer. They're icky and kind of weird. We approach them the same way. We figure out what's being added and subtracted, what's being multiplied and divided, and getting rid of them. The other side doesn't matter. We're getting all of our letters that we're looking for together and getting rid of everything else. So on this one, and this will probably be the last one we do. On this one, again, we want to get y by itself. And I have a couple of options I could do here. I could say, all right, let's get rid of the 2 first, but then I'm going to wind up with more fractions because I need to divide everybody. So I recommend dealing with things that are being added and subtracted first. So we have being added to the chunk I want, because I want y by himself, I have a 2x that's being added. So to get rid of this 2x, I need to subtract it. I need to minus 2x from this side, because I want y all by himself. If I subtract 2x from this side, it's going to go away. I like that, but it means I have to put it over here, minus 2x. So I have a b minus 2x. Can I combine those together?
No.
They just wind up next to each other. So we're going to have our b minus 2x equals 2y. Still wanting to get our y by itself. What do we need to do? Divide by what? 2. Absolutely correct, because then our 2's are going to cancel out. But if I do it to one side, I need to do it to the other. So you can either divide everybody by 2, or you can do like we did in the bell work and divide this by 2 and this by 2. It genuinely does not matter. I tend to, when we have too many letters, just do it in one big fraction like this. Because our y equals this hot mess. Minus 2x over 2. Like I said, our answers may not look better. But since we have y by itself, we did it. I'm going to leave this up here for a second, and I'm going to hand you guys the first homework of this chapter. I know. We have homework yesterday. This one's not going to be due until Tuesday. We don't have school on Monday. So it has a lot of these solid stuff on here, and it's got multi-review on the back. So you guys can actually do everything on here, but we're gonna talk a little bit more tomorrow. I'm gonna get you guys a couple minutes for the call. The quizzes we took yesterday are graded and in. This will be due on Tuesday because we don't have school on Monday. Labor Day. So I'm going to put up the thing. Our chapter test for this chapter is scheduled for September 17th. So this packet will get us all the way through the middle of September. So I just wanted to get that to you before we got to the end.